Okay, today we're going to do halohydrin formation. We have our alkene right here. We're reacting it with halogen in the presence of water. So our expected product should be one of the halogens attaching to one of the carbons that had a double bond, and then on the carbon adjacent to it, we're going to get a hydroxyl group giving it alcohol properties. These are the halogens we can use: F, Br, Cl, I. The I is going to be attaching and detaching. So this is the mechanism. We have the alkene, and then this is all a concerted step. The halogen is going to attack the CH. The double bond is going to attack the same halogen, and this one's going to leave with the electrons. So when that happens, we're going to get the cyclic structure and with the halogen, and we're going to get a plus charge on it. This is going to be plus water, and then this is the X that left with the electrons. The next step, since water is in the picture, so water is going to attack one of the carbons, and then the X is going to take the electrons from that bond, and we're going to get this. We're going to get the X just attached to one, and then we're going to get water attached to the carbon adjacent to it. The formal charge of it is going to be plus because it has 3 bonds, and then the X that is just standing there. So then the next step is we have a base, and that base is going to pick up one of the acidic protons from water, and then we just get the hydroxy group. Okay, let me give you an example of that. So we have our alkene right here. We have Br2, and then this is what we expect to get. So let's show the mechanism for this. We copy the same with a double bond plus Br2, and I'm going to draw the Br like this, Br and Br. So we know that this is a concerted step. This double bond is going to attack the Br. This Br is going to attack the carbon, and then this Br is going to leave. So what we get from that is our structure, and then we get here a Br, a bromonium ion, like that, plus a Br minus in the presence of water. So we know that this Br can attack one of this, and this can leave, and we will get some of that product, but our major product will be adding the OH to this side. We do get part of the product of the anti-addition of the Brs. Then I'm going to copy whatever is there. Like that. We have the bromonium ion right here. Let me circle the formal charge. And then water, the partial negative oxygen, is going to attack that carbon right there, and we're going to get the Br here, and this Br, it takes the electrons from this bond. So it goes like that, and then on this carbon we have H2O, and this is going to be formal charge plus because it has 3 bonds now, and this is going to be plus the Br minus. Now, I'm going to copy whatever is there on this side. We have the Br here, and we have O, H, formal charge plus, and then a base is going to come, and I am going to use for a base another water molecule. And we know polar charges, this is going to be partial negative oxygen. The oxygen is going to attack one of the acidic hydrogens or protons, and the bond is going to make a lone pair for the oxygen. And then we get as a result our molecule with the Br here and then the oxygen down here. I am not showing the stereochemistry again. I did show it up here. I'm not showing it down here because the bond is rotating. It's a single bond, so it rotates. So it doesn't really matter the stereochemistry of it. Okay, let me give you another example of that. We're gonna mix things up a little bit. Instead of water, we're going to use an alcohol. So it's going to be the same reaction. So we expect the oxygen to attach to the adjacent carbon that gets the Cl and whatever is attached to it, and it loses the H. Let's show the mechanism. We copy this part, CH3, CH, double bond CH, bond CH3 plus Cl. I'm going to write it like this. And then we know a concerted step, this one attacks this Cl right here. The Cl attacks a carbon right here. And this Cl leaves with the electrons. Okay? So we show the product of that. We get CH3, CH, CH, CH3, and then we get the chloronium ion with a plus charge, and this is going to be plus methanol, CH3OH, plus the Cl minus. Let me circle that formal charge. Now I'm going to copy whatever is on the product side, right here. CH3, CH, CH, CH3. We make the chloronium ion right here. And then the methanol, we know that the oxygen is partial negative. So the partial negative oxygen is going to attack this carbon right here. And then this bond is going to break, and the chlorine is going to take the electrons, like that. And then what we're going to get is this. CH3, CH, CH, CH3. Then we have an oxygen here. The oxygen has an H here, and on the other side it has a methane. And this one has the Cl. Now, formal charge on this oxygen is plus. It has 3 bonds. And we know that it's not stable with 3 bonds. So it wants to get rid of one. That makes this hydrogen acidic. So we rewrite that in here. Cl down here. CH, OH. I'm going to draw the H on the other side, right here. H, and the CH3 right here. And then the last CH3. And then a base is going to come. So let's say the base comes, and the base is going to attack the acidic hydrogen, the acidic proton, and the electrons are going to go back to the oxygen that has a formal charge of plus. And then what we're going to get is CH3, CH, Cl, CH, O, CH3, and CH3. So we just added from an alcohol, we made an ether.